Hello everyone, welcome back to the another lab session. Today we are going to configure VLAN and VTP on a small network of 4 switches using the packet tracer. But there is a twist. This lab is specially tailored to help you in preparing the VTP test labs, and also it will help you to understand what actually VLANs are and what actually VTP do. So we all aware that VLAN is a logical separation of layer 2. So it basically divides broadcast domains in a switch. So broadcast domain basically is a network segment in which if a device broadcasts a packet, then all the devices in the same broadcast domain will receive it. The device in the same broadcast domain will receive all the broadcast packet, but it is limited to the switch only as the router do not forward the broadcast packet. To forward out that packet to a different VLAN or a broadcast domain, the inter-VLAN routing is required. So there are different VLAN range. If you can see, we have a VLAN 0 and VLAN 4095, which are reserved VLAN, which cannot be seen or used. VLAN 1 is a default VLAN of the switch. So by default, all the interfaces or all the ports are the part of the VLAN 1. So VLAN 2 to 1001, this is the normal VLAN range. We can create, we can edit, or we can delete these VLANs. 1002 and 1005, these are Cisco default for FDDI and token rings. And these VLAN we cannot delete. And 1006 to 14096, these are the extended VLAN range. So by default, whenever we are configuring on a switch, we can able to see these VLANs. But these are the extended VLANs. Now you can able to see this is the network diagram where we having four switches which are interconnected to each other, and one PC is connected to the console. So we can able to access the VTP server from the PC which is connected to the console cable. This is the IP configuration which we are going to configure on the four switches for management access. So in today's lab, our goal is to configure the VLAN and VTP on a network with 4 switches. So this hands-on experience will help you out to understand what actually VLAN is and how VTP works on the switches. This is our network architecture. In today's lab, so we are going to configure a VTP server which is responsible for managing the VLAN's database, and further we are going to connect 3 other switches and configure them as a VTP client. So in the network diagram also you can able to see there are 3 VTP clients and 1 VTP server which are going to be configured. All the links between the switch must be configured as a trunk line. So we have to configure the connected interface as a trunk port, and post that we are going to configure the VTP domain name as test domain and VTP password as Cisco. So we whenever we are configuring the VTP, we have to configure the domain name and the password. After that, we are going to configure 2 different VLANs, VLAN 10 and VLAN 50, and we'll check whether it is getting propagated to the VTP clients or not. So we are going to do the configuration on VTP server, and we'll verify whether the VTP clients are receiving those updates or not. So before starting the lab, so make sure you have a packet tracer installed on your device. So let's begin the lab. So first we are going to create the architecture. We will take 4 switches. This is switch 1, switch 2, then switch 3 and switch 4. We have taken 4 switches. We have to connect all these 4 switches using the crossover cable. So we will take the gig interfaces. Let's say we have connected from gig 1 to gig 1. Then we will connect this to gig 2 to this gig 2. Then again gig 1 to gig Ethernet 1 and gig Ethernet 2 to gig Ethernet 2. So we have connected all the 4 switches with each other. So so we have connected all the 4 switches, and we have to connect one PC also. So we have taken one laptop. We'll connect it via console cable. So we'll connect it through console cable to this particular VTP server switch. So let's name this. This is the VTP server. This is VTP client. So this is client 1. And this is client 2. So we have configured all the 4 switches. We are going to configure all the 4 switches. So this is our VTP server and these are three clients which is connected. One port is showing in orange color, so this is by default STP is enabled on all the switches, so by default this port get blocked, so that's why it is coming in orange color. Rest all ports are coming in green. So let's configure first switch as a VTP server. So we will get into the CLI option first. So post boot up you can able to see the switch information. So you can able to see there are how many virtual Ethernet interfaces, how many fast Ethernet ports are available, how many gig Ethernet ports are available. You can able to see the MAC address of the device, the serial number and the model number. Apart from that, there are other information which is relevant for the switch. Now we have to get into the configuration mode. So we have to type config terminal. So we are now into the configuration mode. By default all the switches are in server mode only. If you run a command show VTP status, once you run the command show VTP status, you can able to see the operating mode as server. You can verify on other switches also, it will act as a server only. By default it is operating in the server mode. Let's say this particular switch is on a client mode or any transparent mode, and if we want to make it a server, so there is a command VTP mode, and if you check there are three options. You can configure this as a client, this is a server, and a transparent mode. So if we want to make it a server, we will configure VTP mode server. So you can able to see this device is already in server mode, so it gave you a warning that device mode already VTP server. Now we will log in into the VTP client 1. We will configure this as a client. So if we check the default status, so we will run do show VTP status, it will show you that VTP operating mode is server. So we want to make it as a client, so we will type a command VTP mode client. So now this setting device to a VTP client mode, and now if you check show VTP status, operating mode will be client for VTP client 1. Similarly we will configure for client 2 and client 3. So again VTP status, if you are checking, operating mode is server. So now we will configure second switch as a VTP client. So VTP mode client, and if you check do show VTP status, so now this switch is also act as a client. Similarly we will configure for fourth switch. So currently it is in server mode. Now we will get into configure terminal, then VTP mode client. Now we have configured three switches as a client and one VTP server in our network. So we have achieved first two tasks right now. Now third task is we have to configure trunk lines between all the switches. So all the links which are connected, we have to configure those links as a trunk port. So first we will get into the servers. In server we have two ports connected, gig port 001 and 002 is connected. So we will get into the interface first, interface gig port 0/1. So now we are into the interface. We have to run a command switch port mode trunk. So now this particular interfaces act as trunk port. Similarly we will get into the second interface gig port 02. Now we have both the interface configured as a trunk on VTP server. Now we will get into the VTP client 1. VTP client 1 also we have connected with those interfaces. So we will get into the interface gig port 0/1. We will run the same command switch port mode trunk. Then we will get into the interface gig port 2 and then run switch port mode trunk. So now we have configured trunk interfaces on client 1 also. So if you want to check the interface which are the part of or which are the member of the trunk port, so you have to run a command show interface trunk. So it will show you which interfaces are the member of trunk port. You can able to see here gig port 001 and 002, both are the member of trunk port. Similarly, we are going to configure it on VTP client 2 also. So we have to go to the interface first, interface gig port 0y1, switch port, switch port mode trunk. Similarly, we will go to gig port 0/2 and run similar commands. So now both the interfaces are on the trunk port. Do show interface trunk. So you can able to see these two interfaces are now the trunk interface. Similarly, we will going to configure it on switch 3. We will get into the configure terminal, then interface, so now all the 4 switches having the trunk interface configured. So each interfaces are now the trunk interface. We can pass the entire VLAN traffic from those interfaces. Now our third task is we have to configure VTP domain name as test domain and VTP password as Cisco. So now we have to configure the domain name. So we have to type VTP domain and whatever the name we want to configure. So if you see it will asking for you the word. So we have to configure the name as test domain. So this is the VTP name. Once you run the command, it gives you a message VTP domain name from null to test domain. So by default the VTP name is always null. So if you check, we have run earlier command, the VTP domain, there is no value written here. But if we run the same command now, do show VTP status, so you can see the domain name is changed from null to test domain. And we have to configure VTP password to Cisco. So same command, VTP password and then Cisco. So now we have configured test domain or the VTP domain name and configure the VTP password. So now next task is we have to configure VLAN 10 and VLAN 50. Two different VLANs we have to configure on the switch, and then we will going to verify whether it is getting populate or propagate on the other switches or not. We have to configure the VTP domain name and VTP password on each and every switches which is installed on the network. So now we have to configure the VTP domain name and VTP password on the switches also which are configured as a client. So we are into the configuration mode. We will type VTP domain, and we have to keep the domain name same as we have configured on the server. So we have configured test domain. So we have configured the VTP domain name as test domain and VTP password as Cisco on the VTP client 1. Similarly, we have to configure on VTP client 2. So this is VTP. So to show VTP status, if you check right now VTP domain name is null, we will configure it. So VTP domain test domain. So now this name changed from null to test domain. Now we will configure the VTP password. So VTP password Cisco. Okay, so we have configured these two settings. We have configured test. We have configured domain name and password. Now if you check the VTP status, it will show you the domain name populating here. Same we are going to configure on the switch 3 also. So do show VTP status. Okay, so VTP domain name is already configured here because it is act as a client right now. So domain name is already configured. We will configure the password here. So we will configure VTP password Cisco. So domain name and password we have configured on all the switches which is the part of our network. Now we are going to create a VLAN in VTP server, and then we are going to check whether it is getting propagating on other VTP clients or not. So you can just have a look into the configuration revision number. So revision number will be incrementing whenever we are making any kind of change in the database. Let's say we create a VLAN or we delete a VLAN, or any modification we are doing on the VLAN, it will automatically change the revision number. So right now if you check, the revision number on the server is 0. If you check revision number on the clients also, it is reflecting as 0. So now we are going to create the VLAN on a VTP server. Then we will check the difference in the revision number on client and server both. So let's say we are creating a VLAN 10, and we will name it as students. So we have named it. Now we will exit. We will check show VLAN status here. So do show VLAN. So if you see, we have created a VLAN 10 with name of student. So you can able to see we have created a VLAN with name student. So so we have created a VLAN with name student. It is reflecting. So we have created a VLAN 10 and it is reflecting in the VLAN database also. Now we will check the revision number in VTP status. So we will run the command do show VTP status. Now you can able to see the configuration revision number is 2. Now we will verify on the VTP client 1 also. So first we will run show VLAN. Do show VLAN. So you can able to see this 10 get propagated on the switch 1 also, and we will verify the VTP revision number also. Show VTP and do show VTP status. So now you can able to see the configuration revision number is 2 on the switch client 1 also. Similarly we can validate on other switches also. Show VTP status. So configuration revision number is 2. Similarly we can verify on the third client also. So here also configuration revision number is 2. So let's say if we modify or if we make any kind of changes in the server, let's say we create one more VLAN. Let's say we create one more VLAN 50, and we will name it as server. So now the revision number for this particular switch will be 4, because we have modified 2 things in here. We created a VLAN and we name it as a server. So now revision number is 4, and we will verify the revision number on other VTP clients also. So now you can check the revision number is 4 on VTP client 1 also, on VTP client 2 also, and VTP client 3 also. So this means that your entire database is getting matched with the server. If you run the command do show VLAN, so you can able to see both the VLANs are getting propagated on the clients. This way you can create a database on server, and it will automatically propagate in each and every switches which are connected in the network. So just make sure that VTP domain name and VTP password will be same on all the clients which are connected to the server. Then only it is going to propagate the entire database. If anything mismatch, it will not forward that particular update to the client. So I hope you find this video useful. In the next video we are going to configure the transparent mode. So that's it for now. Thanks for tuning in. I will catch you in the next one.